Welcome back to Robominions.in AI interview preparation app. The topic of this video is depth first search. Before tracing the code, I request you to watch this video on your laptop or at least make your mobile phone screen full size in a horizontal view so that you can clearly trace the code along with me. If the code is not clearly visible on your laptop, then on your mobile phone, then I strongly suggest you to watch this video on your laptop. The app I am using to trace the code is Robominions.in AI interview preparation app. By just clicking back and next button, you control the code and you can revise before going to an interview or a gate exam or your semester end exam. You can revise all the code and concepts of computer science. The app is available in the website Robominions.in. Download the latest version of the app here. App is regularly updated every 3 months with lots of new topics and a lot of bug fixes. If you have a Windows OS laptop, download for Windows OS. Okay. Now let's start tracing the code. We have this arrow which goes to the exact line of the execution of the code. It helps in tracing the code. So right now it's pointing at #include stdi.h. When I click next, then it goes to #include stdlib. Then we have a macro #define. V stands for vertices, so we have 5 vertices. If you want to go back, then you can click back and it goes back. Okay. So now we have adjacency matrix of size 5 by 5. So let's see. So we have 0, 1 is 1. The matrix represents the directed unweighted graph. This is the graphical representation of this adjacency matrix. From 0 to 1, we have a directed edge. Then we have 2 to 1, 2 to 3, 2 to 4, and then we have 3 to 0. Then we have 4 to 3. So these are directed edges, unweighted graph. And then we have visited of 5 equal to 0, 0, 0. So visited of 5 is initialized to 0. Then we have int main. In int main, we have int first node equal to 2. So from 2, we traverse to other nodes and check and mark them visited. Okay. Now we have depth first search of first node. So depth first search of 2. So we go to depth first search int I. We have printf %d, I. So %d. Now 2 is the first node we are traversing to. Then we mark it as visited. So we mark it as visited now. So once we have visited a node, we mark it it becomes green. Okay. So visited of 2 equal to 1. Then we have a for loop. From 2, we go to other vertices. So j will be from 0 to 4. So from 2, we try to go to 0, 2 to 1, 2 to 3, 2 to 2, and 2 to 4. So let's see. Now j is 0 here. In the for loop, j is 0. We have adjacency matrix of first node, that is I is right now 2. So I is the one. So it's a recursive function. So we have a node from where we try to traverse. So that I is 2 right now and j is 0. So 2 to 0. So 2 to the 0, there is no edge. So 2 comma 0 is 0 and 0 is not yet visited, but false and true is false. It doesn't go inside. J is incremented to 1 now. Then we have 2 comma 1. So 2 to 1, we have a edge from 2 to 1 and its direction is from 2 to 1. You can see the arrow here. It's directed. It's 1 and 1 vertex is not yet visited. So it goes inside the if condition. It calls the depth first search and pass the j. So from 2 to 1 we go and 1 we pass it to the depth first search, and from 1 we do again a depth first search. So from 1, so when I click next, so depth first search has received in the I, it has received 1 now. So we print first we finish the traversal. So we go from 2 to 1. So 1 has been printed and then we mark 1 as visited now. So visited of 1 equal to 1. So visited of 1. Then from 1 we try to go to 0 or 1 to 1, 1 to 2, 1 to 3 and 1 to 4. Okay. Now again we come to a for loop. We have j equal to 0 now. Again int j equal to 0. From 0 we start. We have adjacency matrix of from 1 to 0 we don't have a directed and no directed edge, no nothing. if condition fails, then j is incremented to 1. Now 1 to 1 again is 0, j is incremented to 2 now. Now 1 to 2 there is no directed edge. From 2 to 1 we had, but nothing from 1 to 2. Then again we increment j to 3 now. So 1 to 3 there is no edge, j is incremented to 4 now. 1 to 4 we have nothing, so that is also 0. So 1 to 4 we have nothing, that is also false. Now j is incremented to 5. So end of the for loop, end of the function, and we go recursively back. So from 2 to 1 we went, right? Now from 1 we come back to 2. So when I click next, we have come back. So you can see we have restored the function context. So 2 comma 1. So 2 comma 1. So from 2 we went to 1 and then tried exploring. We found nothing. Then we came back recursively, and then now we increment j in this context of the function. J was 1, so we were at 2 comma 1. Now j is incremented to 2 now. So now we'll check 2 comma 2. So 2 comma 2 is 0. So nothing from 2 comma 2, and now j is incremented to 3. 2 comma 3 is 1. So from 2 we have something. So there is a directed edge from 2 to 3. So we can go to 3 now. So we can go to 3, and 3 is not yet visited. So not of visited of 3 is true. So true and true is true. It goes inside the depth first search. So inside the if condition, we call the depth first search and we pass the j3. So 3 is passed to the depth first search. It goes to the depth first search function. We first print 3. So 2 to 3. And now from 3, we try to go to 0. We try to go to 1. Try to go to 2. Try to go to itself. And then try to go to 4. Let's see. Visited of 3 is marked 1 first. So because we went from 2 to 3, and then we try to go now in the for loop, j equal to 0. From 3 to 0, from 3 to 0 we have a directed edge, and 0 is not yet visited. So then we go inside the if condition and call the depth first search on. From 0 we go to, from 3 we go to 0 now. Okay, we call the depth first search, j is 0, so we pass the j 0. Print first from 3 to 0, we print 0 now. So 0 has been printed. Then we mark it as visited. So 0th vertex has been marked as visited with 1. And then we again call the for loop. Now j equal to 0. From 0 we try to go to 0, 0 to 1, 0 to 2, 0 to 3 and 0 to 4. So from 0 you can see, let's see. First we have 0 comma 0. So 0 comma 0 is 0. So and it's already visited. So it fails. Now j is incremented to 1. Now we come to 0 comma 1. So 0 comma 1, from 0 to 1 we have a directed edge, but 1 is already visited. So true and not of 1, that is false. True and false become false. Doesn't go inside the if condition. Now j is incremented to 2 now. 0 comma 2. So we have 0 comma 2 as 0. So 0 comma 2, 0 to 2 there is no edge, that becomes false. Then j is 3 now. 0 to 3 there is no directed edge. From 3 to 0 we had, but nothing from 0 to 3. Now j is incremented to 4. 0 comma 4, from 0 to 4 we don't have any edge, again false. Now j is incremented to 5. End of the for loop, comes back, and when I click back, the function, so you see, you have to remember, from 2 we went to 3, from 3 we went to 0. I hope you remember, 3 to 0. So from 2 we called the recursive function to 3, then we called a recursive function to 0. Now from 0 we have finished the traversal, so the recursive call have ended. Now 0, it has to come back to 3. When I click next, it restores the context of 3. So if you come back, so visited 3 equal to 1, adjacency matrix 3 comma 0. So this 3 comma 0 has been done now. Okay, and 0th vertex has been visited. I hope you are with me now. Now when I click next, now j is incremented and we start looking for other vertices, 3 to 1, 3 to 2, 3 to 3 and 3 to 4. So rest of the vertices are checked in the adjacency matrix. So when I click next, j is incremented to 1 now. So we have 3 comma 1 is 0. There is no edge between 3 comma 1. When I click next, j is incremented to 2 now. There is no valid edge from 3 to 2. There is no directed edge. Now when I click next, j is incremented to 3 now. So 3 to 3 is also 0. There is no valid edge. Now when j is incremented to 4 now, 3 to 4 there is no valid edge. So there is nothing. And then j is incremented to 5. End of the for loop comes out of the depth first search. Now comes out of the for loop and comes out of the depth first search. From 3 we go back to 2 now. So 3 we go back to 2. The reason is our recursive function has ended. Okay, we go back to 2. When I click next, the function at this place, whatever the context was there, that will be restored now. So when I click next, see, you can see everything has been restored. So adjacency matrix of 2, 3, from 2 to 3 we have finished. Now we proceed, increment the j is 3 now, so j will be incremented to 4, and we go from 2 to 4 and try to visit. I click next, j is incremented to 4, 2, 4 is 1 and 4 is not yet visited. So we go from, so we call the depth first search on 4 now. So when I click next, so depth first search of, first we visit the node 4. So 4 has been visited, mark the 4 as 1, and then from 4 we try to reach to 4 to 0, 4 to 1, 4 to 2, 4 to 3 and 4 to 4. So using for loop j equal to 0. So 0 less than 5 is true. 4, 0. 4, 0 is 4 to 0. There is no edge, so nothing. So it is 0. It becomes false. J is incremented to 1 now. 4 to 1, we don't have any valid edge. Again becomes a false. 4 to 2, we have from 2 to 4. The arrow is from 2 to 4 direction, but nothing from 4 to 2. So that is also fail. Then we have from j equal to 3, that is from 4 to 3. Let's see, from 4 to 3 we have a valid edge, but 3 is already visited, so it is marked 1. So it is true and false is false. So comes out of the if condition. Now j is incremented to 4. From 4 to 4 we have nothing, so it becomes false. And 5 less than 5 is false. So end of the for loop. Now from 4 we go back to 2 now. So when I click next, the context is restored, and now we increment j to 5. So from 2 we are done from 2, and we end of the 2, and then end of the, so end of the, from 2 we have already found, we have traversed through all the vertices, and end of the for loop, and now coming out of the first node. So end of the depth first search function, it goes back to the main, and we have traversed from 2 to 1, 3, 0 and 4, and written from the main function. And the time complexity of this algorithm, recursive algorithm, is order of v square, where v is the number of vertices. So we have to go through all the vertices, and from that vertex we have to go through all the vertices again. From every vertex, so that is the reason it is order of v square. Okay. So if you want to access the code, you can click on the code button in the app and get access to the code. And if you want to revise the concept by just clicking back and next button and traverse the graph yourself, it's a beautiful app that is Robominions.in AI interview preparation app. You can step by step revise the concept and prepare for your interview, GATE exam, or any semester or other competitive exams, and understand the concepts clearly. The app is available in the website Robominions.in AI interview preparation app. You can click on download here. The app is updated every 3 months with a lot of new topics and a lot of code. You can download if you have a Windows OS laptop, download for Windows. Thank you guys. See you in next video. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.